Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Welcome to Lesson 8.5, summarizing data using measures of variability. And basically the whole piece here is we're going to look at a really specific portion of a box plot today, and that is the interquartile range. Okay, so we're going to talk about finding that. So just a little vocabulary. The variability of a data set is the spread of the data. It describes how spread out or close together the data values are. Right? For example, if we are asking everybody in this class how old they are, right, everybody's going to say 10, 11, 12, except for the adult in the room who, is 40, 50, 60, 100. Right? So the data, for the most part, very, very spread, one outlier. If we ask everybody in the building how old they are, the data might be a little bit more spread out because we have 5th graders, we have 6th graders, we have young adults starting their career, we have older teachers ready to retire. So if the values are closer together, like in this room, then the data is more consistent, right? Consistently in this room, everybody is 10, 11, 12. If the values are more spread out, then the data is less consistent. Two different measures of variability, right? Measures of variability are numbers that describe the spread of the data. Right? The two examples are mean absolute deviation and the interquartile range. Mean absolute deviation we're not going to deal with a lot here, but I do want you to be available of what it is, right? So this is the absolute value from the mean. And that's how you determine how close you are to being in the center. Okay? So you would find the absolute value, you would find the mean, and then you would calculate the absolute value away from the mean, and that kind of tells you how close or spread out your numbers are because you can see how close they are to the average, right? Obviously, a higher MAD, right, would be more spread, right? That means that the numbers are very spread out, right? Whereas a lower MAD would mean that they are more consistent. All right, more consistent, less spread. Okay. Right. The interquartile range, right, the one that we are going to focus on more closely here, is the difference between the 3rd or upper quartile and the 1st or lower quartile, right? It is a comparison. It is a comparison of the middle 50%. And if you'll recall on a box plot, right, we're going to draw one with no number line, right? This is the 1st quartile, and this is the 3rd quartile. And so we're talking about the data that falls inside the box portion of the box plot. That's what we're talking about. The dot plot here shows Anne's science quiz scores, right? I'd like you to draw a box plot and then find the interquartile range. So I will help you get started, but then I am going to pause the screen and do the work off camera. So I would invite you to try your best to calculate this box plot, construct this box plot on your own. So what I am going to help you get started with is on a dot plot, each of these dots is a quiz score. So she had 178, she had 3 79s, she had 180, 181, 2 82s, oops, and we'll just turn that into an 8. That says 2 82s and an 84. Do you need to write the numbers out like that? No, you could probably just use the dot plot, but I prefer to have them written out in a line. So at this point, you need to calculate the 5-number summary and construct that box plot. So as you can see, here is the box plot for Anne's science quizzes. Right? She consistently is a high C, low B student, right? All 9 of these quiz scores, fall really pretty close together. Right? Now, calculating the interquartile range, right, again, is going to be the third quartile minus the first quartile. Okay? And I'm going to show you kind of both ways, right? From the 5-number summary, we can see here, right, that we would have 82 minus 79, right? Third quartile, first quartile. Also, though, over here on the box plot, if you are given, right, the diagram instead of the 5-number summary, you need to be able to pull those numbers off. There they are, right? But the IQR is 3, right? That's a very low IQR. That means that this data is very consistent, right? In the middle 50% of her scores, right, what she's going to do most frequently, she only has a difference of 3 points, right? She is hovering around a C plus, B minus in science. Okay. The dot plot shows the distribution of Anne's health scores. Find the IQR. In this second example, I'm only going to find the 5-number summary because I don't feel that creating the box plot would help us. So if you want to pause the screen and find the IQR on your own, fantastic. If you want to follow along, that's great too. So here we go, right? We've got an 84, an 86, an 88, a 90. I should have given myself more room. A 92, a 92, a 94. All right. So minimum is 84, maximum is 94, median, that middle number, right? Low, high, low, high, low, high, 90. Great. That first quartile then is going to be from these 3 numbers. Middle number is 86. That third quartile is going to be from these upper 3 numbers, 92. Okay. IQR, interquartile range, third quartile minus first quartile, middle 50% of the data, 92 minus 86, interquartile range of 6. So with this last question, we're looking to compare some things from the 2 previous problems. So you're going to need to know the IQR of her science and her health scores, right? As well as the general kind of spread of the data. So you can look at the dot plots, you can look at your box plots, you can look at the IQRs. I would invite you, though, to pause the screen and to try to come up with a statement of your own to compare and contrast this data. Okay. I pulled some of this stuff from a couple of the previous slides if you need to back up to verify, right? In science, the IQR is 3, right? That middle 50% of her data scores was a difference of 3, and the range from the lowest to the highest score, right, was 6 points. In health, her IQR was 6, right, and her range from the lowest to the highest was 10, right, so a little bit more spread out. And when I look back at the data, I was able to come up with this conclusion, right, that it appears that Anne does better in health, right? Her scores in health are higher. However, the scores in science are more consistent, right? She is consistently C plus, B minus, whereas in health, some days she is as low as a low B, right, but as high as kind of a middle A. So if this stuff isn't making sense to you, please come and see me. This section is designed to get us to talk about the consistency and variability of data. So if you don't have any questions, I would log on and complete the 8.5 Practice Buddy, and have a great day.